So what if a factory could actually tell you it was about to break down? I mean, weeks before it even happens. Well, today, we're going to dive into how AI is turning industrial machines into something like fortune tellers, moving us out of an age of costly surprises and into an era of, well, predictive genius.
Just picture it for a second. Some huge, complex machine on a factory floor. Now, what if that machine knew, with pretty amazing accuracy, that a critical part was about to fail? And what if it could automatically schedule its own repair for the most convenient, most cost-effective moment possible? I know, it sounds a little like science fiction, doesn't it? But believe me, it's happening right now.
So, to really get how this is possible, we've got to look at the massive leap we're taking from just old-fashioned guesswork to genuine data-driven prediction. Honestly, this one single shift is what's driving this entire revolution. Let's break it down.
All right, so the old way of doing factory maintenance, it basically runs on a simple clock. A part gets replaced every 1,000 hours whether it needs it or not. This is pure guesswork, right? It's all based on averages, and it leads to two really bad outcomes. Either the part fails unexpectedly before you replace it, shutting down the whole production line, or you waste a ton of money replacing a part that was actually perfectly fine. The new way, the AI-powered way, basically just throws that clock out the window. It uses real-time data to literally see into the future, preventing downtime and optimizing every single decision for cost and performance.
Okay, so how does a machine actually know it's about to fail? This is where we get to the real brain of the operation, the AI optimization engine. We're essentially teaching machines how to think and plan ahead.
The secret sauce behind all of this is a concept called remaining useful life, or RUL for short. Now, don't think of it as just a simple countdown timer. It's way smarter than that. Think of it as the AI's expert prediction. It's constantly analyzing how a machine is actually being used in the real world to calculate exactly how much time a specific part has left before it's likely to fail.
But just knowing a part might fail is kind of useless without a plan, right? So here's how the AI turns that RUL prediction into real action. First, it plays the role of the fortune teller, constantly calculating that RUL for every single critical part. Second, it becomes an economist, weighing all the cost of a new part versus the cost of a catastrophic shutdown. And finally, it becomes the master planner, crunching all those variables to generate the single most cost-effective maintenance schedule possible. It's this perfect blend of prediction and pure practicality.
And this is where you really start to see the true scale of this technology. It's not just about one little pump or one motor. The AI can look at an entire fleet. Think of a huge wind farm with hundreds of turbines. By intelligently grouping repairs for multiple turbines at once, companies have been shown to slash their maintenance costs by over 10% compared to just fixing things one by one. We're moving from individual fixes to system-wide intelligence.
Now, having an AI brain is fantastic, but it needs a nervous system to connect to the physical world, right? And that brings us to our third section, connecting the factory with something called the Industrial Internet of Things, or IIoT. This is the essential question, isn't it? I mean, how does some fancy algorithm sitting in the cloud get real-time, super accurate information from a hot, vibrating, and really noisy factory floor?
Well, the answer is you have to build a digital nervous system for the factory. It all starts with sensors. These are like the nerve endings, collecting data on everything from vibration to temperature. Now, for speed, a lot of that data gets processed right there on site. That's a concept called edge computing, before the huge data sets are sent up to the cloud. That's where the AI brain does its heavy lifting, training and refining its models. And here's the crucial part. The AI's decisions are then fed directly back into the company's own software to automatically create the work orders.
And that last step, that is the real game changer. This isn't about a manager getting an email alert that they might just miss. No, this is about the system linking a prediction directly to an action. The AI sees the future problem, and the system automatically schedules the repair, orders the part, and assigns the technician. The entire loop is closed, a lot of the time without any human needing to do a thing.
Okay, so this all sounds great in theory, but come on, does it actually work in the real world? Let's take a look at the results and see the tangible impact this technology is having right now.
So the number one benefit you hear about in nearly every single case study is a dramatic reduction in unplanned downtime. For any manufacturer, unexpected stops are the single biggest killer of productivity and profit. It's just a nightmare. AI-driven maintenance tackles this problem head-on, turning what used to be a constant risk into predictable, reliable operations.
And the savings? Oh, they are very real. Remember that wind turbine example? That wasn't just a theory. Research confirms that this kind of fleet-level optimization leads to real-world cost reductions of over 10%. And when your assets are worth millions and millions of dollars, that is a huge number.
And this success isn't just in one little niche industry either. We're seeing this approach deliver incredible results everywhere, from logistics and semiconductor manufacturing all the way to aviation and energy systems. In fact, case studies are reporting reductions in unplanned downtime anywhere from 10% to over 60%. This is a proven, high-impact strategy, no doubt about it.
So what does all of this mean when you put it together? Let's zoom out in our final section and talk about building the smart factory and what experts are calling the dawn of maintenance 4.0.
Here is a really key insight from all the research. The AI algorithm, as powerful as it is really only one piece of the puzzle. Its value is only unlocked when it's supported by a full ecosystem of good sensors, seamless data integration, and smart, company-wide processes. The point is, you can't just go out and buy the AI, you have to build the smart factory around it.
And that very combination, that blend of smart technology and smart processes is exactly what defines Maintenance 4.0. It's basically the fourth industrial revolution, Industry 4.0, applied specifically to keeping our world running. It's all about creating these integrated, intelligent, and self-aware industrial systems.
All of this leads to one final, really big question. When our factories can reliably predict their own futures, freeing up human ingenuity and brainpower for even bigger challenges, what's next? What new levels of efficiency and innovation does that kind of future unlock? Because that is the world this technology is building, right now.